Right, one of the things that makes teaching chemistry hard and harder than a lot of other classes is labs. And it's one of those things where the biology teacher's not going to be able to help you a whole lot with doing chemistry labs. Physics teacher's not going to be able to help you a whole lot. Um, but also amongst all of the sciences, chemistry is by far the most dangerous. There's a lot more risk involved in a chemistry lab than most biology and most physics labs. So you got to be selective, and that's kind of the first major tip I've got for you, is that you got to be selective because your time is limited. Prepping labs and cleaning up labs is time consuming. It just takes time, especially if you're going to do it the right way. Add to that just the stress of teenagers with chemicals and things that break. It's just stressful. For that reason, I strongly encourage you, be selective. Every lab you do needs to be for a purpose. It is not about the wow factor. It's not about being the cool teacher who does the cool, crazy things. It's about using your labs and your demos to facilitate learning. Remember that a simple hands-on activity works sometimes just as well. Like, for example, when I'm doing ionic nomenclature in your resources, and I talked about when we were doing ionic nomenclature, I have a little activity with cards that I use for showing that. I use candy and toothpicks to do Vesper. Those are great activities. They count as labs, but the cleanup's easier. I don't have to worry about the kids. It makes it a lot easier on me. Demos. Some things are just easier to do as a demo, where you do it from up front and you show them what it looks like instead of having them do it. They need to do labs. That's important, but you got to be selective and you got to do it, in the best way that's to be safe. Which is why our next big tip is be safe. So as the teacher, it is your responsibility to keep everyone safe. It is your responsibility to know what all the risks are in a lab and to deal with it and to be ready to deal with it and be ready to respond. And I'm going to guide you through how to figure out what all the risks are. Now, some of the risks are always the same. Don't horseplay. Things can break. If you break glass, here's what you do with it. Those are pretty common, but individual chemicals have their own risk. And it's your job as the teacher to know what those risks are and to minimize them and know how to respond to them. And so that's your responsibility as a teacher. You also need to keep your safety in mind because you're the one who's going to be exposed to these chemicals over and over and over again. Every period, every year, every semester, you're the one who's going to be exposed to these. I had a teacher that I worked with in my student teaching. The other chemistry teacher next door was having major health problems. She's coming up on retirement, but she was a chemist early on in her career and was exposed to dangerous chemicals. And she was having all sorts of health problems from that chemical exposure. I personally don't want to have that happen to me when I'm coming down on retirement. And so I limit the hazards to myself just as much. Also, we generally tend to, when we do demos because it's a little more hazardous, and we're doing it ourselves, and we've got to keep that in mind. So, like I said, doing demos limits risk for students, but we've got to do safety for ourselves and safety for students. If you're doing something with fire or sodium and water, you got to keep the students back, and they got to have eye protection on. You got to be careful of keeping enough distance. You don't want kids up in your space while you're doing a demo of a toxic chemical. And even then, if you're really concerned, the best, safest thing you can do for really dangerous reactions is YouTube. There are a lot of really cool reactions on YouTube that I am never going to do in my lab because they're just too dangerous. The chemicals are too nasty. And the camera can get closer than I can to watch it. And so I use YouTube a lot as well. Once again, just primarily for this to limit risk. So here are some just general tips that you may remember from high school chemistry or college chemistry, but just some general tips when you're doing things in lab. So first, Whenever you're diluting an acid, you want to do, the way the saying goes, do as your otter, add acid to water. That way, if there's any spills, it's the water that's spilling, that's splashing out, and not the concentrated acid. Because you pour water into acid, if it spills really quick or splashes out, like it oftentimes when you first start pouring something in, you have concentrated acid splashing out, which is bad. And so you want to do acid to the water. It is not uncommon for solutions to give off a large amount of heat when you dilute them or when you make them. Sodium hydroxide and sulfuric acid being two good examples. You want to put the container into a water bath or a sink of water to help keep it cool. I've almost melted a plastic bottle or two because I forgot this and was like, oh crud, and needed to run to the sink and get some water going to keep it from melting the bottle. And that's the other thing. If it's like in this situation, like I made a mistake, but I knew what to do with it. Now I'm new, like, oh wait, I need to get this under running water. I need to cool it off, and so I was able to deal with that mistake. That's kind of what lab safety is. It's you're not always going to be perfect. You're going to make mistakes. Things are going to happen. Things are going to break. Things are going to get spilled. But the question is, do you know what to do with it after that happens? That's what lab safety is really about. It's not being perfect and never making a mistake. It's when mistakes happen, what do I do with them? Okay. There are a lot of great resources out there. My favorite is Flynn Scientific. They have a great website. Their chemistry catalog has amazing information on safety hazards, but also how to clean up chemicals. And they do have kits, but I recommend not using the kits, which is my next point. Just avoid buying kits. They can clutter your lab really, really badly. It's better to calculate how much chemical you need, and then to make those solutions to that amount. Maybe a little bit extra in case kids spill or need to redo a lab, but for the most part, if I need only a liter of something, I'm just going to make a liter or a half a liter. I'm going to make it and do it myself because it's quick. It just saves down on the clutter in the storeroom. Because it's easier to store a bottle of concentrated hydrochloric acid or 6 molar hydrochloric acid. I prefer the 6 molar stuff just because it doesn't scare me quite as bad. Concentrated acids scare me. I don't want them spilling on me. But 6 molar is much stronger than I'm ever going to let kids use in my lab. And so I'll buy that because I feel more comfortable with it. And then I'll use that and dilute that down to the concentrations that I need. Same thing with copper chloride. I'll buy the powder, weigh it out, mix the solution. If you need help on making solutions, ask me. I can go over that in office hours, or I can email you something that kind of goes through how to make solutions. All right, think about disposal when you're planning a lab. Because lab cleanup's a big part of your time. So the two things that come into play are how well does the chemical clean up? For example, is it something that I can just flush down the drain, or is it something that I need to actually do chemical treatment on? It matters. And then you can limit the amount. If you have less of the chemicals that you've got to clean up, it's going to take less time to clean up. So for example, if I'm doing something that has a chemical that's a little bit more of a pain to clean up, or I'm doing like a double displacement reaction, I'm going to have precipitates that I need to filter out. It is so much easier to do that with smaller amounts of materials. So I would use test tubes to do my double displacement reactions with precipitates. And then the kids can dump it into waste beakers, and then I can filter it out. And usually I pick chemicals that I can then, the liquid part, after I filter out the precipitates, are things that can go down the drain. Because I pick chemicals that I know are safe to go down the drain. If you're not sure whether or not something can go down the drain, you can Google it. Flynn Scientific Catalog is great because it tells you what things can go down the drain and what can't. You can also look at the material safety data sheets, which we're going to go over in a little bit, on those chemicals as well. And you can see what can go down the drain and what can't. And once again, I tend to really try to limit my risk and limit my time constraints by picking chemicals that are easy to clean. All right. once again, if you're not sure, check a catalog. You need to do that as much as possible. So those are just kind of the general tips. And if you need help as you get into the year, then once again, that's what office hours are going to be for. And I'll be there to kind of help you run labs safely.